In the first three explainers for hyperbolic trig, we found hyperbolic cosine, hyperbolic sine, and we found that identity that's very similar to the regular cosine and sine one, except there's a subtraction because that's how hyperbola work, right? There's a minus there between the x and y instead of a plus, and it forms a completely different figure that's equally fascinating as a circle, if there was even possibly such a thing. Because hyperbola in a lot of ways are kind of an inverse of a circle. Okay, now we're going to talk about, maybe you've seen it written like this, arc hyperbolic cosine and arc hyperbolic sine, because what could get more complicated than a phrase like that? And the only thing you need to remember from the first three are hyperbolic cosine itself, which is e to the negative x plus e to the x over 2. Okay, and you may remember that it looks like a hyperbola, even though it's above the x-axis like this. And the left side of the function is dominated by the negative x portion, and the positive x portion dominates this side of the function. And its converse, hyperbolic sine, is similar, but I always write it this way because the only difference is this is a plus and this is a minus. So sometimes, and maybe I'll say always, written differently in textbooks, but this tells the truth. Let me get my x's in there correctly. This tells the truth about how similar they are. It's just a minus sign that makes them different there. And of course the divide by 2 is because you're averaging the two functions together wherever you are. Now we want to find their inverse. And it might seem like, oh, we just do the y equals x kind of thing, but I'm going to give you an intermediary step that makes it cool. Let's do cosine first because it's all pluses. And all pluses tends to be easier. So if I know that this is hyperbolic cosine, then what I'm going to do is I'm going to set hyperbolic cosine to y, like this. And to find it, we're going to find x, because if y equals hyperbolic cosine, then x is hyperbolic arc cosine. They're inverse functions. So right now we've solved for y, which is hyperbolic cosine, and that means that the x will be the inverse function of that. So what I'm going to do is try and find x. And first we're going to multiply by 2. That should be fairly obvious. But from here, things are going to get a little wild, because solving for e to the negative x and stuff, that could be really hard. So what I'm going to do instead is I'm going to bring in a third variable. I'm going to say u. And u is going to equal e to the x. And that'll just solve that problem for me. So now we can rewrite it like this. 2y equals u to the minus 1, which I'm going to write as 1 over u, and then plus u. That's much nicer. Doesn't that look nicer than this? That's the beauty of algebra. We can just make things equal things, can't we? But I still hate this inverse here. So what I'm going to do is I'm going to multiply by u across the entire equation. So on one side I'm going to get, doesn't look very good, 2yu equals 1 plus u squared. And if I bring this over, I end up with a u squared minus 2yu plus 1 equals 0. Then what does this look like to you? Do you remember the quadratic equation? It's a quadratic equation. And you might not remember, but I'll write it one time because algebra was about 4 years ago, and you thought I'll never need to know that again. How wrong you were. How wrong you were. And the only way I know this is because I wrote it down. I did this video earlier and I recorded the wrong screen because I'm stupid. But this part is correct. And I simplified this, so I'm going to bring it back here. And I'm just going to write it as 4y squared. Like that, minus 4 over 2. So that you can see when I bring it out that this is going to be gone because the 4 is able to come out of the square root as a 2 and be canceled. So what I ended up with was y plus or minus the square root of y squared minus 1. Now, I believe that the plus or minus is not accurate because when it comes to the e to the x stuff, this starts to get weird, but I'm going to leave it for now. And this is my u value here. But what was u? U was e to the x. You know, e to the x equals this. So what I want to do is I'm going to take a natural log of all of this, like this. Because what does this become? ln of e to the something is just the something. So x is going to equal the natural log of y. And I did check, only the plus version works. Plus y squared minus 1. So this is arc hyperbolic cosine. Because we switched it. Remember way up here? We did it. That's the first one right there. So when you see this identity here like this, and of course we can usually write it oppositely. So you usually see like, I'll use this notation just to make sure that we see it in there. Equals the natural log of x plus the square root of x squared minus 1. So we use x as the algebraic term for input. But that is the inverse of our classic hyperbolic cosine. And I misused my thing there because I'm moving fast, but I'm just trying to make a point. This is our arc hyperbolic cosine. Now what about arc hyperbolic sine? Can we follow the same convention? Are we going to be able to use the quadratic formula? My hope is yes. So let's say y equals negative e to the negative x plus e to the x. And all this will be divided by 2. We'll multiply by 2. Say 2y equals negative e to the negative x plus e to the x. And now, with a little bit of practice, you know that we're going to make a u equals e to the x. So we can say that 2y is equal to negative, is it? Is it negative? Take a look at this for a minute. You tell me. I believe it's negative u to the negative 1 plus u. Or if we multiply everything by u, 2yu equals negative 1 plus u squared. Bring the 2yu over. Starting to feel a little better than last time, I hope. So you get kind of the idea. We get u squared minus 2yu minus 1 equals 0. Quadratic equation time, mofo. You got to do it. Can you walk me through it? Tell me in the comments section, honestly, if you forgot the quadratic equation, because I had to go look it up. I haven't taught it since last year, and I already get it wrong again. So I always just look it up. And what do we want to do here? U equals 2y plus or minus the square root of 4y squared plus 4 over 2. So again, the 4's can come out, make a 2 here, and the 2's everywhere cancel out. We're going to get a u equals y plus or minus the square root of y squared plus 1. That's a little different, because this one was a minus over here. It's not a small difference. It looks like a small difference till you look at the behavior, but it's not. And of course, we know that u is equal to e to the x, right? And so to get x, we need to take a natural log of this whole thing. And we'll say x equals the natural log of y plus, and again, the minus doesn't work for the domain. And we'll probably leave that out of this video because it just will further confuse something that's already a natural log with a square root inside by finding that I'm going to write it as hyperbolic sine to the negative 1 like that. So to put in the input formula, you're going to get this. And the only difference here is this +1 and this -1 here. So you may be provided these identities most of the time, but I've seen a couple of tests where you're asked to derive this. And before you just go pumping it in, you should make sure that you can derive this, because this is how math works. This is what math is. It took me a couple tries, but I got comfortable with it quickly. And as you go through the steps, it's not like it's a secret. You don't need to not know how to do it. Walk through these steps until you get how to do this. Substituting u for something complicated here happens more and more as you move into integral calculus. They even have an integration method called u substitution. So this is not something you should skip. I get that it's scary looking, but it's mostly just in the words to make non-math people think that this is hard. There's a quadratic equation. You did that in 7th grade or something for the first time. I'm sure that by now we should be able to accomplish it. And sure, you might get it wrong once or twice, but that's math, baby.